Alright, let's go over this. Did you guys write your letters above and below? Class Y equals what? A B X. Class your A value is? 1/3. B value? Remember, it can't be 0 because 0 times anything changes it all to be 0. Okay. C value. There is none, so none means what number? 0. And D value. Right? It's kind of like, would you have something like this? And then there's no number there, so it would just be 0. Okay, class, previously the A value would help you find the... So remember, if you take the absolute value of A, absolute value of 1/3, it would be what? But we just took notes that the amplitude for tangent and cotangent is? It's not real, it is fake. I'll show you what that means once we graph it. Your B value helps you find the period. Partner A, tell partner B, what's the formula for the period for tangent? Damien, what's our formula?
Pi over B.
Pi over B. Our B value is 1, so our period is pi. Class, what does the C value tell us? Yeah, so there is no phase or horizontal shift, right? There is no parentheses. It's not going to move off the origin. You're going to start at the origin. And your D value tells you what? It's not going to go up or down, so that's no vertical shift. All right, I want to show you guys my paper. I'm going to make my table of values up here, and I'm going to leave pi about half of a page for the graph of tangent. Okay? All right, so let's go ahead and make our table of values. Let's do that parallel with what we're doing down here. So normally we did 5, 1, 2, 3, 4, 5. I'm leaving a little bit of space to expand my graph to the right. And we're actually going to draw over 2 periods to see this. Let me also clarify phase shifts. Class, do we have a phase shift? Do we have a C value? No. Now, normally when we did a phase shift, we put it between what? But the period for tangent is what? Put your finger on it. Not the answer here, but here. It's over pi. So if I put everything to the right of the trig function between 0 and 2 pi, it just tells me on my graph I'm starting at what? 0 and ends at pi. And we normally would have done that without it. So it's essentially the same thing. So let's go ahead and put 0 and pi. Alright, with your partner, go ahead and take a minute. I want my 5x values. Class, how do you make pi a fraction? We're going to make it a 1. And I can always double it to find equivalent fractions. If you double this, what do you get? 0 over 2. It's kind of weird, right? How about this one? Essentially, you have something like 0 pi and 0 pi for 2. 0 plus 2? 2 divided by 2 is, so this is just going to be 1 pi over 2. Now, the reason why I doubled them, 0 plus 1 is 1, and 1 divided by 2 gives me 0.5. We normally would not write like 0.5 pi. Why? Because you don't want decimals with a bunch of fractions. So we're kind of making them all in the fraction family. Same thing over here. Class, what's 1 plus 2? And 3 divided by 2 is 1.5. So I wouldn't write 1.5 pi over 2. I'm going to double these again, and you'll see it. Class, double that. This one. And that one. So 0 plus 2 divided by 2. 1 pi over 4. 0, 1, 2, 3 pi over 4. So let's go ahead and circle these now. I'm going to circle the most reduced one to use. So what am I going to circle here? Next one. Again, I have the decimals there to kind of show you that we don't want decimals and fractions. That's why I keep making equivalent fractions. You'll notice that they kind of go in neat lines, right? And you'll actually notice that this is actually good work for us as we work with it above. Let's go ahead and write down those circled ones above. So I have 0, pi over 4, pi over 2, 3 pi over 4, and pi. And that matches $1, doesn't it? 1/4 of $1, quarter, 50 cents, 75, $1. Alright, so we just wrote down our 5x values. We're going from which direction, class? Right to left. It's essentially PEMDAS. PEMDAS. Because there are no parentheses or exponents, then you would do multiplication. Now we have to do what? Not multiply by tangent, but evaluate at tangent. Let me do the first one, and I'll let you guys do the rest. If I draw out the unit circle, now again, if you haven't memorized the unit circle, that's fine, but then you would have to kind of figure this out on your own. Tangent at 0, what's the order pair? And the order pair is labeled x, y. Cosine, sine. Now, for now, you guys don't know the quotient identity, which would be sine over cosine. But we do know that tangent in terms of x, y, and r is y over x. Tangent is, let's write that somewhere, tangent is y over x. That's from like a long time ago, right? So class, tangent at 0 is 0 divided by 1, which is 0. Let's do one more, because pi over 4. Tell your partner what the order pair is at pi over 4. The answer is 1 pi over 4. You have radical 2 over radical 2. Remember, it is x y, so it's radical 2 over radical 2, which is?
1.
1. Something over itself is 1. We're okay? Let's just finish this together. Tangent at pi over 2. Put your finger on the order pair. 1 divided by 0 is? Undefined. 3 pi over 4. 3 pi over 4. You have a positive radical 2 over a negative radical 2. Negative 1. Now, again, the reason why I'm not counting these 2's because this is x over r and this is y over r. Does that make sense? So you don't really need the denominators. Or if you actually divided the fractions, you'll see that the 2's cancel out. So negative 1. And tangent at pi. 0 divided by negative 1. 0. Okay, we found our x values, we evaluated a tangent, and now we need to do what? Before we graph it, are we going to add 1/3 or multiply? Multiply by 1/3. 1/3 times 0 is 0. 1/3 times 1 is 1/3 times undefined is undefined. 1/3 times negative 1. And 1/3 times 0 is 0. Alright, let's graph this. Yeah. Oh, tell your partner what is undefined going to look like on the graph. Class, it's going to look like a? Yeah, broken is a vertical asymptote. So at pi over 2, I'm going to have a vertical asymptote. You can put 1/3 anywhere you want on your graph. Let's say I make mine 5 boxes. Then I'm going to have to count 5 boxes down. 1, 2, 3, 4, 5. Messy. Okay, let's graph this. 0, 0. I'm just reading the order pairs above, right? Pi over 4, 1/3. Pi over 4, 1/3. Pi over 2, undefined. 3 pi over 4, negative 1/3. And pi is going to be at 0. That looks kind of weird, right? Okay, so what we need to do now is we need to kind of go a little bit to the right and a little bit to the left, and you'll kind of see the graph. Okay? So this might be the first time, which I should have shown you earlier, is if you want to draw more graphs. Additional periods. So notice how we needed 5 points. 1, 2, 3, 4, 5. I'm going to count from the asymptote. 1, 2, 3, 4, 5. And I'm also going to do that to the other way. So starting with the asymptote, count with me. Ready, set, go. Okay, every 5th point, and you can evaluate with the table of values, but every 5th point is going to be a vertical asymptote. Every 5th point is going to be a vertical asymptote. One, two, three, four, five. 1, 2, 3, 4, 5. Watch my finger and watch the pencil. Same. Move over to the next point. Same. I don't have one here, and this one is at negative 1/3. Move it over another point. Same. X-intercept. Move it over again. Same. I have nothing here. It's going to be 1/3. Move your finger over again. Same. They're asymptotes. Do you see it? Alright, let's go ahead and draw our graph now. Your graph's going to look like a snake. You got to go through those 3 green points. One hint about tangent is that you'll see these 3 points in a line. And you'll learn that later in calculus, that the tangent of a graph is actually the slope that is connected to the line. That's the derivatives, right? So that's how you know you're doing them correctly for tangent and cotangent. What's something new is that you're still evaluating tangent. And the only difference in this problem is that we just changed the amplitude 1/3. Why is it a fake amplitude? Amplitude in the previous problems. Let's go find a previous problem. The amplitude was normally something like this. Do you see it? From the maximum to the midline, or the minimum to the midline. That was an amplitude. But in our problem, can I measure amplitude? No, because it goes into infinity. Does that make sense why it's a fake? The period of the graph, the ones that we graphed were here. Now it's kind of weird because it doesn't show the whole graph, does it? That's why I expanded it to the left and to the right. Now even if I expand it to the left and to the right, it's kind of hard to see. This is pi over 2, and if you keep counting, this will be 3 pi over 2. From 3 pi over 2 minus 1 is 2 pi over 2, which is a distance of pi. So this, between the two asymptotes, is a graph period of pi. Okay? And then we didn't move it vertical or horizontal. So this is the wonderful, awesome graph of tangent.